So first up, I am going to pass it over to Grace to start things off by sharing her research on using computer vision to analyze bumblebee behaviors. I'm going to pass it over to you, Grace, to share your screen.
Sweet. Well, thank you so much, Alex, for having me. This is a really cool opportunity. I'm going to be talking to you all today about how we've been using computer vision to understand bumblebee thermoregulation under heat and nutrition stress. And I'd like to start by thanking my lab mates in the crawl lab, especially Acacia Tang and August, for their work helping this project come to be, and my stats consultant, Stephen. And then this work is funded by the USDA and University of Wisconsin. And then I always have to thank the bumblebees that we use for kind of giving their lives to science. So first we'll talk about heat waves, why we're interested in them and what they are. Heat waves are abnormally hot periods relative to the average local temperature, and heat waves are increasing in frequency and severity due to global warming. I probably don't really need to tell you that. We've all been experiencing this over the past 10 years or so. Um, but why we study heat waves is because temperate ectotherms, like insects and like bumblebees, which I'll be talking about, may be more vulnerable to heat waves than average warming. So the like plus 1.5 degrees Celsius is not as dangerous as heat waves can be. Okay, now the fun part, we get to talk about bees. Bumblebees are an important wild and managed pollinator in temperate ecosystems, and they're a social system, which is super cool. And it means that they are able to collectively thermoregulate their nests. When it gets too hot, that induces fanning behavior, where they try to convectively cool the nest by flapping their wings really fast. And although we know that this behavior happens, we have very limited understanding about how this behavior changes throughout the course of a heat wave. And heat waves don't just happen for 4 hours, they can happen for multiple days. And so that's what we were really interested in studying. So first we ask how fanning changes throughout a heat wave. And then second, if nutrition quality impacts thermoregulation, because we know that bumblebees are not just facing stress from heat, but also often from nutrition. Okay, so our kind of null hypothesis was that as the heat wave turns on in this red line here, that there would be an increase in fanning in response to increased temperature, but then they would just be able to maintain that throughout the entire heat wave. As there's this constant stress, they'll maintain a constant rate of fanning. But that seems a little unlikely because the bumblebees would also be experiencing thermal stress throughout this heat wave. And so what we otherwise expected was that fanning would actually decline throughout the heat wave. So although that they have this constant heat stress going on, they wouldn't be able to maintain fanning. And we expected this result to be stronger for the low resource bees, that they would decline in fanning faster and not reach as high of a fanning amount. Okay, so we use Bombus impatiens. This is a bee that is native and widespread in the eastern United States and is quickly becoming a model system. And we made, per round that we made 16 microcolonies with 5 bees and about 3 brood cells per microcolony. So we take bees from this large colony and put them into little boxes, and they're able to kind of establish like mini colonies, and we're able to study their behavior that way. We exposed them to a 3-day heat wave at 35 degrees Celsius and we had a ramp rate of 0.1 degrees per minute. And I just want you to make a note that temperature does not change throughout the heat wave. And then our 2 nectar concentrations, so that's our high and low resources, were a 50% sucrose and 25% sucrose nectar. And we know that this 50% is preferred for bumblebees in the field and in lab. Okay, so then we get to kind of the harder part of setting up this experiment, how we recorded videos. So my lab mates August and Raphael and I set up this kind of monster rig to record videos. We used Raspberry Pis attached to Raspberry Pi cameras to autonomously record videos on a set schedule. We recorded about 50,000 individual videos of 20 seconds each, which is so much data. And so in order to not like drive me crazy, we use computer vision to be able to understand that data. Okay, so we tracked individuals throughout the experiment using Aruco tags that we kind of glue onto their thorax. And then we labeled a bunch of the bees, whether they were fanning or not fanning. And then we used that data to train an efficient B7 supervised classification model. So this is my little deep learning is happening figure. And then hopefully I'll be able to show you what that looks like. So these red bees are fanning in this video. You can watch that one more time because it's cool. So that was really cool that that worked. It took a long time. But yeah, and I'm happy to talk a little bit more about that too later. So I'm just going to share this fanning result. Oops, okay. So on the y-axis, we have normalized fanning. So that's, lower, less fanning, higher, more fanning. And then time elapsed in the experiment since the heat wave started. And then the darker purple line is the high resource and the low is the pink. And so we do see, sorry, that fanning does decline throughout the heat wave, which is a really novel result and something that we would not have been able to access without using computer vision. And we find that bees in the high quality group fan more. Sorry, I'm getting over a cold. Sorry, I think I'll have to end there, but you guys can read these.
Well, thank you so much. I'm so sorry that you're not feeling well or getting over a cold. This is awesome, and I definitely have questions that I might put in the chat for you to answer, to not make you speak, and I encourage other people to do the same. But what I will say is that I would love personally, and I think the Wild Labs team would as well, to see some reviews from you and your lab mates on Raspberry Pis and the Aruco tags that you guys used on the inventory, our wiki-style database of conservation tech, which I will drop into the chat later on. But thank you so much for that presentation, Grace.